Okay, we're going to learn all about right triangle trigonometry in this screencast. And the first thing you need to understand is how we refer to the different parts of the triangle. So if you are standing at this corner here, then you are looking across to this side, and it's the opposite side. The longest side is always the hypotenuse, and the other side that's next to you is called the adjacent side. Once we know how all those pieces are labeled, then we can define our trig terms. So the trig function sine is defined to be the opposite side over the hypotenuse. The cosine of theta is defined to be the adjacent side over the hypotenuse. And the tangent of theta is the opposite side over the adjacent side. And you can remember that by this little mnemonic. So katoa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that's so katoa. That's a good way to remember it. We also have reciprocal functions. The cosecant of theta is the reciprocal of sine, so it's hypotenuse over opposite side. The secant function is the reciprocal of cosine, so it's hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so it is adjacent over opposite. So let's say we're given a triangle and we're asked to find the 6 trig functions of theta. So this is a right triangle, and one leg is 3, the other leg is 4. So by the Pythagorean theorem, the hypotenuse is going to be the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is the square root of 25, which is 5. You may have already figured that out because a 3, 4, 5 right triangle is pretty common. Okay, so now we know all of our pieces. Here's theta down here, and the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. The tangent of theta is the opposite over the adjacent. And cosecant is just the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Okay, how about this triangle? This is a 45, 45, 90 isosceles right triangle. So the sine of theta, or actually we know what theta is. Theta is 45, right? So the sine of 45 is 1 over root 2. That's the opposite over the hypotenuse. And we usually rationalize that denominator and call it root 2 over 2. The cosine of 45 is the same thing. The tangent of 45 is opposite over adjacent, which is 1. So now we know the cosecant is root 2, the reciprocal of 1 over root 2. The secant of 45 is also root 2, and the cotangent of 45 is the reciprocal of 1, which is 1. All right, now here's a right triangle you're going to deal with a lot, and that is a 30, 60, 90 triangle. And so now we're going to do the sine of 30 degrees. So we're standing down here. Our opposite side is 1. The hypotenuse is 2. The cosine of 30 degrees is going to be the adjacent over the hypotenuse, and the tangent of 30 is going to be 1 over root 3, which is root 3 over 3. And I will not go through the secant, cosecant, and cotangent. I bet you can do that on your own now. Now what about getting the sine of 60? Can we do that with this triangle? We sure can. Now let's change our position so we're standing up here at 60 degrees. That makes the root 3 side, the opposite side, 1 is the adjacent side, and of course 2 will always be the hypotenuse because it's always the longest side. So if I'm up here now, then the opposite over hypotenuse is root 3 over 2. The cosine of 60 adjacent over hypotenuse, 1/2. And the tangent of 60 is going to be root 3 over 1. Now take a look at this. The sine of 30 is equal to the cosine of 60, and the cosine of 30 is equal to the sine of 60. That makes them what we call cofunctions, and we can say that the sine of 90 minus theta is equal to the cosine of theta. In other words, sine of an angle is equal to the cosine of the complement of that angle. Now, we're going to be dealing with 45 degrees and 30 degrees and 60 degrees so much that you probably, well, I'm sure your math teacher is going to ask you to memorize this box right here. So if you want to pause this screencast and copy that down, I would advise it, because this is all information that every math course involving trigonometry would expect you to know from memory. So I spoke earlier about how sine and cosine are cofunctions, which means that the sine of a complement of an angle is equal to the cosine of the angle. And of course that works the other way too. Cosine of a complement is equal to the sine of the angle. Secant is a cofunction with cosecant, and tangent is a cofunction with cotangent. So those are useful to know. All right, here is another box of really important information. We have the reciprocal identities that we've talked about. You can also write tangent as a quotient of sine over cosine, and since cotangent is the reciprocal of tangent, that means that it's cosine over sine. And the Pythagorean identities are very important. If I take the sine squared of an angle and the cosine squared of that same angle and add them up, it will always equal 1. So, for example, cosine squared of 20 degrees plus sine squared of 20 degrees equals 1. And if I divided everything by cosine squared of 20, I would get 1 plus tangent squared, because tangent is sine over cosine. And 1 over cosine is secant. So 1 plus tangent squared equals secant squared. And that's 20, right? So that's where this comes from. These are just different forms of the original Pythagorean identity. Okay, so let's do some examples. If tangent of theta equals 3, what is cotangent of theta? Well, since cotangent is the reciprocal of tangent, it's just going to be 1/3. Okay, what about secant theta? Okay, well, remember that 1 plus tangent squared equals secant squared. So 1 plus 3 squared equals secant squared of theta. And that's 1 plus 9, which is 10. So that means that the square root of 10 is the secant of theta. Okay, so we're going to do one more example of applications of trig. And this one involves getting the height of a building. So let's say that you've got a person standing here, and they're 2 meters tall, okay? And they are also 100 meters away from the building. And she sights up to the top of the building and measures what's called an angle of elevation. It's always measured from the horizontal. Okay, and that angle of elevation is 47 degrees. So we'll call that y. And there's 2. So y, this is a little right triangle, isn't it? Y is the opposite side. 100 is the adjacent side. Since we know since we're looking for the opposite and we know the adjacent, we will use tangent. So we're going to say the tangent of 47 degrees is equal to y over 100, which means that 100 times the tangent of 47 will give us y. Let's get our calculator up, and let's make sure that we're in degree mode. We are. So I just go 100 tangent 47, and we get 107 meters. And don't forget that we need to add on this 2 meters right here. So the total height is 109.2 meters.